All right, so today we're continuing 5.1. We're going to identify different types of variation from data, and then we are going to do some more story problems with variation, which we also practiced yesterday. So first, let's just do a quick review of identifying some variation. Ian, what's one type of variation we talked about yesterday? Okay, and in direct variation, what's our equation?
Y equals k of x. Y equals kx.
Yes.
Okay.
All right, good. Direct variation. Cam, what's another type? Good. Okay, so we also have joint variation. And then do you remember what that equation is?
Y equals kx.
Good. Y equals k times x times z. Guys. Okay, and then Lauren, what's the last one?
Inverse variation, y equals k over x.
Good. Okay, and then we have inverse variation, which is y equals k over x. Now, notice that direct and inverse both use two variables. If you have joint variation, you need how many variables? 3. Okay, so for this one, you do have 3 variables, 3 unknowns. We're also going to talk about some combined variations today. So the 3 variables in this one are your x, your y, and your z. So for our first example, it says determine whether each data set represents, and it should say direct, not direction. So whether it represents direct variation, inverse variation, or neither. All right, so it's either direct or inverse or none of those. Why, even just looking at these blank tables, would joint variation not be a possibility?
Because there are only 2 variables.
There are only 2 variables, right? Your x and your y. So let's think about how can we decide if the table shows direct variation. Yeah, Macy?
If it has like the points for a linear.
Okay, and good. And what made you think of that?
Because for direct variation, when it's graphed, it can only be linear.
Okay, yeah, so you're going to have direct variation, which is a linear equation, so it should fit that linear model. Yeah, Cam, you want to add to that?
If there is a 0 anywhere, or like in the x, if there's a 0, because you can't put a 0 in for inverse.
And then if you did have a 0 for the x, well, not necessarily, right? If you had the 0 in for,
Can't do it for inverse because it's on the x would be, you can't divide by 0.
yeah, so your k wouldn't be able to be 0 because that means that it would be a constant function, but your x could be 0.
But isn't it under the radical?
What's that?
Or not under the fraction, it can't be 0.
If you were solving for it, and that part, it would be undefined. But if you have direct variation, aren't you always gonna go through 0, 0? Because that's your y-intercept. So if you have 0 for x, you would have 0 for y. So that wouldn't be necessarily something that we would look for in that case. Because you should have that point on there. Going back to the fact that this is linear, how could we tell from a table whether or not something was linear?
First differences.
Okay, the first differences. And the first differences were always equal to what? When we found the first differences, what part of our equation did that represent? It represented the slope, right? So your first differences in a linear equation represent the slope. Yesterday we talked about how the slope in direct variation is going to be what? It's going to be your k value. It's going to be what's in front of x. So really what we have to do to find if the first differences are constant, we have to see if the k is constant. Well, how are we going to find if k is constant if we're using y and x? Is this an equation we can solve for k?
Yeah.
Okay, so let's do it. So if you have y equals k times x, you divided both sides by x, then k would be y over x. All right, if we're finding y over x and those have to be constant, what would we call y over x? What's something that we would? Yeah, good, a ratio. Okay, the comparison of your two values. Okay, so for direct variation, the ratios y over x need to be constant. Okay, so then what we're going to do for direct variation is divide. So what you're going to do is you're going to see if these ratios are constant. Okay, and this would be direct variation. Okay, now if it's inverse variation, with inverse variation, we start with y equals k over x. So if we want to solve this for k, whenever you have a fraction, to move it over, you need to multiply. So this is x times y. Okay, so in this case, for inverse variation, what has to be constant? What will we call x times y? What's the result of a?
Product.
Yes, a product. Good. Okay, so for inverse variation, the products, x times y, need to be constant. So it is kind of a backwards way of thinking because you're solving. If it's inverse variation, it's the products are constant. Okay, for both of them, k is constant. It's just if it's inverse, it's the product. If it's direct, it's the ratio, which is the opposite of what the original equation is. Okay, if you do both of these and k is not constant, then it's going to be neither. So we're going to do the first one together, and then I'm going to give you some time to do B and C. So for part A, your x values are 6.5, 8, 13, 14, oh yeah, sorry, 13, 4. I'm just really good at counting, so. Okay, and then you have 104 over 0.5. All right, so I usually check the direct variation first. When you're doing this on your homework, you can choose which one you want to do first, and if you do find it on the first try, you don't have to go through the second. Okay, so the first thing I'm going to check for is direct variation. All right, so for direct variation, I am seeing if my y over x ratios are constant. So I'm going to do 8 over 6.5. And remember, we are continuing our no calculator. We are getting in tip-top shape for our SAT, PSAT, which is in less than 3 months. Okay, so activating some of the skills that we have, but we haven't used in a while, so we might need just a little refresher. All right, so if I'm trying to figure out if these are equal, the easiest way to do that is to get a common denominator. But we also talked about yesterday, if you have 0.5, the simplest way to create a fraction from that without the decimal is to multiply this by what? Yep, so we're going to multiply by 2 over 2. Oh, and yeah, we also talked about 10. So if it is a decimal that you just have to move, if it's 0.5, the reason why I just do 2 is because that will make it a whole number. So 8 times 2 is 16. 6.5 times 2 is 13. Now, right away, I can see 16 over 13 is not going to equal 4 over 13. So if you were doing this on your homework, this would be enough for you to go on to the next one. Okay? I'm just going to show you what this equals so we can practice. So when you do a half times 2, you get 1. This would be 1 over 208, okay, which obviously is not equal either. So this one cannot be direct variation. Okay, so no, ratios are not equal. All right, so now we're going to proceed to inverse variation. Okay, so what we're going to check here is the x times the y. Remember, what we're doing here is we're doing x times y because that's what equals your k value. That's what we're seeing as constant. So now we're going to set up our products. So 6.5 times 8, 13 times 4, and really the simplest one I think is going to be the last one, to do half of 104, because half of 100 is 50, half of 4 is 52. Okay, now you could write this out and do it, or you can also, remember we can take parts and multiply them together. So we know 10 times 4 is 40, yep, and then 3 times 4 is 12, 40 plus 12 is 52, so that's looking good. When we multiply this, what two numbers would I multiply first? Yep, 6 times 8, which is 48, and then I would add that to 8 times a half, which is 4. 4 plus 48 is 52. Yay. Okay, so the products are constant. So this is going to show inverse variation, and then we're going to write what the equation is. Okay, so since the product x times y is constant, the data shows inverse variation. Okay, so then if we were to write an equation that models this, remember, what we found is k is 52. So if k is 52, your equation, this is an inverse variation equation, y would equal 52 over x. Okay, so this would be your equation. Okay, so I'm going to give you your values for B and C. So you have 5 and 30, 8 and 48, 12 and 72, okay, so then I want you to do those with your group members. Again, just make sure you are showing your steps. If you didn't write those down, will you do that for me, please? I know, but show what is going to be constant. If you do get direct or inverse, remember, write your equations.
Wait, what's inverse relation? Universal. So what's inverse relation? Only there was this.
Okay, if you are finished with that, go ahead. You can go on to the back and then read the story problem. If you're still working, just take a few more seconds to finish up. So, hey Ethan, if your group's done, will you read the story problem on the back to your time? Right, if your group's done, then I want you to read through the story problem on the back and see if you can set it up.
That's what I said.
Okay, so let's come back and look at part B. Okay, so attention up front, please. I want to make sure you got this down. Your direct variation, when you do your ratios, you should get 6. That's your K value. So that's direct variation because your ratios are equal, and your equation would be y equals 6x. Okay, and then for part C, for direct variation, I got 5/3 and 7/3 was the reduced fraction, so I knew those were not going to be equal. For the products, I got 15, 84, and 168. Those were not equal, so it is neither. Okay, so again, remember when you're doing this, when you're finding K, you're doing the inverse operation of what you did before because you're solving. So direct is usually when you multiply, but to solve for K, you have to divide. Okay, inverse is when you are dividing, but because you're finding K, you're doing multiplication. Okay? All right, so for example 2, I asked you to read over that. Like I said, on your quiz, you are going to be writing out the equation, so we're going to focus on that. Also, whenever you have your story problems, make sure that you are labeling your units. Okay, and no calculator, so put your calculators away. Okay, so this is the time t needed to complete a certain race varies inversely as the runner's average speed s. What I would do right away is identify what my equation is going to be. So knowing that it varies inversely, t is what I'm going to start with. I have k on top, and then it varies inversely with the average speed s. So I know that's going to be the form of my equation. Your first step is going to be to write the equation, and to do that you do have to find k. All right, now in the next sentence they tell you if you have a runner with this speed, and she completes the race in 2.97 hours. What is the average speed of a runner who completes the race in 3.5 hours? And I like to highlight the question, what they're asking you. What is the average speed if you complete the race in 3.5 hours? Okay, so again, when you're doing your quiz, you are going to have to find your equation, so that's what we're going to practice doing today. So we already know that T is going to be K over S. Now, they always are going to give you values that come in a pair, or sometimes they will come in 3. So if you know that it's 8.82 when the time is 2.97, you can plug those in to your original equation. Okay, so the 2.97 is T. It's your unit of time. The average speed is going to be your S. So we're going to have 2.97 equals K over 8.82. All right, whenever you're trying to solve for the variable on top, you have to multiply both sides by your denominator. Okay, so then we're going to multiply these two decimals together. So we want to activate our prior knowledge on how we're going to multiply when you have decimals. Do you guys remember the rules for that? What's the first thing you do? You're going to move the decimals. Okay? Some of you guys might need to look up here if we don't remember how to do this. So we go 1, 2, 1, 2. So all together I moved 4 decimal places. Now I can just multiply like normal, and then I can move the decimal back 4 places when I'm done. Okay, so for this one, 2 times 7 is going to be 14, carry the 1. 8 times 7 is 56, plus 1 is 57, carry the 5. 8 times 7, 56, plus 5 is 61. And then remember here you put your placeholder. I'm going to be quiet for a few seconds so you can finish that, and then I'll talk through it if you're having trouble. Max, put that down. I don't even want it on your desk. Guys, it's really frustrating when I told you several times that you're not using calculators. If you're doing that now, your quiz is going to be incredibly difficult and you're not going to finish in time. And then once you start on your second row, you're going to do 9 times 2, which is 18, carry the 1. 9 times 8 is 72, plus 1 is 73. 8 times 9 is 72, plus 7 is going to be 79. So it's important for you guys to go through that practice. Those are all math facts that you know, but if you haven't done it in a while, it just takes you an extra second to think about it. 2 times 2 is going to be 4. 2 times 8 is 16, carry the 1. 16 plus 1 is 17. And then we're just going to add straight down. Okay, and 7, 8, 9. This is 15. 15 plus 6 is 21. 9 and 7 is 16. And then you just have to move back 1, 2, 3, 4. Okay, and then we're just going to round this to the nearest 10th. So this is going to be 26.2. Once you find your K, now you can set up your equation. Okay, so your equation is T equals 26.2 divided by S. All right, and then for step 2, we now need to find the average speed, which is S. Okay, when we know that the time is 3.5 hours. Okay, so remember we are going to label our units. The average speed is measured in miles per hour, so we're definitely going to make sure we include that in our answer. Once you plug in 3.5 for t, okay, and then you have the 26.2 over s, notice that the variable's on the bottom. So we said over here that you're always multiplying by the denominator. You can multiply both sides by s and then divide, or you can also set this up like a proportion, because if it's set up like a proportion, what strategy do we use? Yeah, what kind of multiplication? Yep. So you can set up a proportion and cross multiply. Right? So if I just put 3.5 over 1, I can think of this as 3.5 times s equals 26.2 times 1, which is just 26.2. And now I'm going to divide. Now, I have 2 decimals, so this would be a good time to do what? Cam, this would be a good time to do what?
Multiply by 10.
Yes, because even though you have 0.5 on the bottom, right, if you multiply it by a half on the top, you're still going to get a decimal. But when you multiply by 10 over 10, that moves the decimal over one place. So now I have 262 over 35. Okay, we're going to turn this into an improper fraction. The reason why I'd want to do that instead of reduce is because if I have 35, what are 2 things you know go into 35 right away? 7 and 5. This is an even number, so 5's not going to go in there. Okay, it's unlikely that 7 will go in there. But let's estimate to see if we can come close to how many times 35 goes into 262. So first start thinking about approximately how many times does 35 go into 100? Definitely twice, but almost 3 times, right? It's 33 and a third. That would be exactly, well, the 0.3, I have to keep going. So if it's 200, couldn't we estimate that that's going to be at least 6? Okay, possibly 7 times. So let's see what happens when we do 35 times 7. Okay, and this you can also think of as 30 times 7 is what? 30 times 7 is 210. And 5 times 7 is 35. You can think of it like that. Or you could do the carryover, 21 plus 3, 245. So how much would be left over? How much would be left over? So I had 262. If I took out 245, how much would be left? 17. So I have 7 and 17 over 35. 17 over 35 is approximately what? It's almost a half, isn't it? Wouldn't 17.5 be exactly half of 35? Okay, so this is going to be approximately 7.5 miles per hour. Oh, did you guys do the long division? Yeah, yep. And you could do long division too, just like we did yesterday. I'm just giving you more strategies that you guys can use. Okay, so you can absolutely do what we did yesterday. All right. Example 3 starts off talking about the change in temperature. So it's the change in temperature T of an aluminum wire, and that varies inversely as its mass M and directly as the amount of heat energy E. Okay, so we have 2 different types here that are combined. So your equation, there's only going to be one equation, but we're going to combine these 2 together, okay? So I want you to see if you can set up part of it. but it won't be y. Okay, so Chris, tell me what you're thinking. How could I start this? Well, you always are going to start with what part?
Divide.
Okay, and what is the...
T.
Yeah, okay, so t is going to equal...
Is it n over e?
that. So if
Oh, e over n.
it varies inversely with m, right? So if it's inversely with m will go on the bottom. Well, what do we have to have on the top if it's inversely? Yeah, your constant k. Okay, and then, yeah, if it's directly as e, normally we just multiply. So if I'm multiplying this, the e, like you said, is going to go on the top. Okay, so it's the two of these combined. If you just had t equals k times e, that would be the direct. If you had t equals k over m, that would be the inverse. All right, now it says the temperature of an aluminum wire with a mass of 1 kilogram rises 5 degrees Celsius when 450 joules of heat energy is transferred. Have you guys talked about joules in your science class yet? Okay, so joules is a way to measure your energy. So let's go ahead and categorize what we have. So the mass is 1 kilogram. Your temperature, 5 degrees Celsius, that's your change. And then your energy would be your 450 joules. Okay, so we are going to solve for K. So I have 5 equals K times 450 divided by 0.1. Now there are different ways you could do this. You could do the division first. I'm going to multiply both sides by 0.1 because I think it's easier to multiply 0.1 by 5 than to think of the division part. I'm just showing these in your different steps so I can show your canceling. All right, so if we do 5 times 0.1, what is that?
0.5.
Just 0.5, right? Because if you do 1 times 5, it's 5. You're just moving the decimal back. You can also think of it as 0.1 plus 0.1 plus 0.1 plus 0.1 plus 0.1. Okay, now I'm going to divide by 450. And you could set this up as a division problem. But again, we have a half. And what's the strategy we've been talking about with a half? Multiply by 2 over 2. It's really you're multiplying by 2 over 2 because what is 2 over 2? 1. And when you multiply by 1, you get the same thing, so it doesn't change your value. What's 2 times a half? 1. What's 2 times 450? 900. Okay. You could also, like I said, if you have a half divided by 450, yeah, isn't this just multiplying by the reciprocal? Yeah, so it's still 1 over 900. All right, now when you plug this into your equation, you're going to have t equals 1 over 900 e times e over m, which is one way you could write the equation, or you could simplify it. The reason why I want to go over this is this is a skill that you'll need for your PSAT. They actually, a lot of times, will do alternate forms of equations, so I want you to know how to simplify this. Really, if you're multiplying something by a fraction, this gets multiplied by what part of the fraction? Nope. It's always multiplied by the numerator, whole number times the numerator. So you could think of this as e over 900 divided by m, which we really wouldn't keep something that looks like that. We would write this as e over 900 divided by m, or e over 900 multiplied by the reciprocal. So all I'm doing is using what we know about multiplying fractions and dividing fractions. E times 1 over 900 is E over 900. If I'm dividing by m, it's like I'm multiplying by the reciprocal. And when I multiply across, E times 1 is E. I'd have 900m here. This would be an equivalent form. Okay, and really you could use either one of those for your next step, right? And that's E over 900m. So once we have our equation, now we are going to answer the question, which is how much heat energy must be transferred to the aluminum wire with a mass of 0.2 kilograms to raise its temperature to 20 degrees Celsius. Okay, so what this is asking you to do is find the heat energy, which the heat energy is E. Okay, so we're going to find E, okay, when the mass is 0.2 kilograms and the temperature is 20 degrees Celsius. Okay, so I'm going to use this first one here. I'm going to show you how you can use the other one too. So I'd have 20 equals 1 over 900 times E divided by 0.2. Okay, so the first thing I do is move over the denominator, which is multiplying by 0.2. Okay, for 20 times 0.2, again, you can just think of this as 2 times 20, which you know is what? 40. Now, how many places did I move the decimal? 1. So I'm just going to move it back 1. 4.0 is 4. Okay, so it's 4 equals 1 over 900E.
Then multiply each side by 900.
Exactly. Then multiply each side by the reciprocal. And 4 times 900, just do 4 times 9, 36, and then add your 2 zeros in. And then remember that you want to put your units so that the energy would be 3,600 joules. Okay, now like I said, you could do the same thing with this equation. If you had 20 equals E over 900 times 0.2, you could multiply those two together first and simplify, or you could just multiply both sides by 900 times 0.2. And again, you'd end up doing 900 times 0.2 times 20, which is 4 times 900, or 3,600. Okay, so either one of those you could do. Okay, so your 5-1 day 2 homework, I want you to do this on the same page as your 5.1 day 1. And I'm going to check both of those tomorrow if you did them, all the 5-1s together. Okay, so this one is 13 through 16, 27 through 31. So if you did your 5-1 day 1, I'll check that tomorrow with the 5-1 day 2. Make sure that you guys are showing your work, because if you're not showing your work, I'm going to assume that you use your calculator.
This thing I put on page because
I'm just going to check them together.
Well, I filled up the page yesterday because I had to work all my work.
Yes.